Welcome to the Mood Ring Part 1, Exploring Color. In this video, we're going to learn about the technology of how computer screens and TV screens are made. Pause your video now and take a moment to navigate to Activity 9. I'll see you there. Activity 9. In this activity, we learn how the artist Georges Seurat developed a technique known as pointillism that is now used in technology to create the pictures on TV screens, computer screens, and cell phone screens. Let's take a look at the painting up close and personal. I'll go to the next page, Control, touchpad to the right, and here we see a painting that hangs in the wall of the Art Institute of Chicago. And this painting is a beautiful scene of a number of people enjoying a day at the park. But let's see how it was actually painted. Now I'm going to zoom in a little bit more closely to see exactly how this was done. Take a look right in here at the grass and the skirt of the woman in the shadow, and you can see that the way that this painting is actually made is that the artist drew the brush into a very fine point by licking it with his lips and then dabbing it into the paint on his palette according to the color that he wanted, and he applies it to the canvas in such a way that all of the points, when taken together, create this stunning image. And so pointillism is a really cool technique where we can see that the entire painting is not made with smooth brush strokes, but instead by little dots of paint that have a particular color. Well, how does this relate to a calculator and a screen? Well, let's go to the next page and we'll try to see what's happening. So on this scene we have a view of the calculator, and here's a little Python program that I've written. And over here you can see that this is actually a microscope that is a video microscope that is being played over here in the screen on the right. Just to show you how the microscope works, I'll turn the light on the microscope and I'll take my Tempo, a coin from the Edo period in Japan. I kind of like coins, and I'll zoom it in here and you can see that my microscope picks up the brass that this coin is made with, and it shows it in very close detail of what the coin's structure looks like, that brass, and you can see the minting of the numbers and all of that. So it's very interesting. But we're not interested in coins today. What we're interested in is how does this calculator screen work? Well, what I'm going to do is I'm going to run my program. So I'll run this program. And notice that all it does is it paints the screen a particular color, in this case, of course, red. Let's slide the calculator screen underneath the microscope and let's see what it looks like. There it is. And now if we look over here, you can see that this is actually, the screen is nothing but a bunch of LEDs in an orderly array. Remember from our previous activities that an RGB LED has three elements in it, a red, green, and blue element. That's why it's called RGB. And those red, green, and blue elements of each individual LED that's on the screen, you can see this screen has quite a few, over 100 LEDs just in this view, that these can all be turned on independently of whether the element red, green, or blue is on. So I'm going to press escape and switch the color of the LEDs to green. notice that the little rectangles moved up over here. And that's because the element for the green is slightly above the element for the red over here in the array. But it appears green to our eye, and we don't see all of these little dots, just like we didn't see all the dots in the pointillism painting. If I press the escape again, I now switch the screen color to blue. Again, you can see the rectangles have shifted. And if I press escape again, I'm now making a secondary color on the screen of yellow. And you can see over here that yellow is made by turning on the red and the green LED components. Hey, this is exactly what we did with the hub, and we wrote software, that is a computer program, that controls this. I'll press escape again, and now you can see that the screen color is cyan, and that's made from turning on the blue and the green of the LEDs. If I press escape again, I now have magenta, and we've learned that magenta is red and blue, and here you can see the red and the blue elements are turned on. And if I press escape again, now the screen is white. Notice that the white of the screen kind of matches the white of this background cardboard that I'm using. And over here we can see that that white, it's kind of crazy, but it's made up of all these colors. This red, green, and blue, all of these red, green, and blue LEDs turned on appear to my eye as white. Remember that our eye perceives white, but it is going through all of that business of perception that we talked about in the previous activities. So this is kind of cool. We can see that white is turning on all of them. If I turn off all of the LEDs, my screen appears black, and of course all the LEDs are turned off. Now, if we go back to the prompt here, it looks like these are all on, but let's take a look at really what we're looking at. You see, here's my calculator in the Python shell, and it has a message right here. Let's look at that message up close and see, how do you actually write a message? Well, if we look at that, hey, look, there's my greater sign from the Python prompt. And the way that it's done is by turning on the background white, turn on all the LEDs, but then turn off the LEDs to make the character that you want. And so here we can see there's the greater, and here's the writing from FROM. And you can see that this is the writing that's on the screen. It says from magenta, that's the name of my program right there. And so it's kind of cool. So now we've learned how a computer screen and a TV screen work using the knowledge that we've gained from programming the RGB LED on the TI Innovator Hub. And we learned how the painting of Georges Seurat and his technique of pointillism has developed this same idea in art well over a century before the TV was ever invented. So this is all pretty cool stuff, and I hope that you've enjoyed learning about color and how things work. And I hope that you stay tuned for our next video, our next challenge, that will take you into more Python programming on the TI Nspire.